KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Good morning students. Today we'll start an important chapter, that is trigonometry. It's a very important chapter. You get trigonometry properties, trigonometric concepts will use in each and every chapter of mathematics, almost every chapter of mathematics, not only in maths, will use more often in physics also. It's a very important chapter. You know all formulas and everything from this chapter. Now, first of all, what is the word trigonometry? The word trigonometry, it is derived from a Greek words, that is trigon and metron. Okay, tri means three, gon means sides. Okay, three sides. Metron means measurements. So it means measuring the sides of a triangle. Measuring sides of a triangle. Okay, trigonometry is derived from Greek words trigno and metron. Tri means three, gon means sides. Okay, metron means measurement. It means measuring the sides of a triangle. Okay, in trigonometry, first thing we'll know what is an angle. What is an angle? Okay, angle is a measure of rotation of a given ray about its initial point. Okay, now suppose this is the initial side, this is the initial side OA. Okay, ray OA is initial side. Now this is rotated to certain extent to reach the terminal side OB. Okay, OA is rotated, okay, to certain level so that we reach terminal side OB. This amount of rotation is called an angle. Okay, is called an angle. Okay, when you rotate anti-clockwise direction, angle is positive angle. When rotation is clockwise direction, angle is negative angle. Now here this example, now OA, OB, now OA is rotated in anti-clockwise direction to reach OB. Okay, this rotation is anti-clockwise rotation, so this is a positive angle. Whereas in this case, this is OA initial side, this is OB terminal side. This rotation is what? Clockwise direction. Okay, now clockwise direction is negative angle. Okay, but this point of rotation, now about a point O we are rotating, about a point we are rotating, this point of rotation is called vertex. Okay, this point of rotation is called vertex. OA, OB, OA is rotated to reach OB. Okay, so this measure, okay, how much it is rotated, this is an angle. Okay, now here it is written, angle is a measure of rotation of a given ray about its initial point. Okay, about its initial point. Angle is measure of rotation of a given ray about its initial point. Okay, but the original ray is called initial side. This is initial side. Original ray is called initial side, and final position of ray, it is called terminal side. Okay, original ray is called initial side and final position of ray is called terminal side of the angle. Okay, this point of rotation is called vertex. Point of rotation is called vertex. Okay, To calculate angle, to measure angle, we have various methods like degree measure, radian measure, grading measure, okay, but we'll use degree measure and radian measure. Okay, now before going to degree measure, now here this is initial side, this is rotated again to terminal side is also initial side, means initial side is rotated so that again the terminal side also is the initial side. This is called one complete revolution, one complete revolution, okay, revolution where initial side and terminal side coincide, okay, this is called one complete revolution. Okay, next. Now methods of measuring an angle. Methods of measuring an angle. First method is degree system or sexagesimal system. Okay, in this system one complete rotation is divided into 360 equal parts. One complete rotation is divided into 360 equal parts. Each part is 1 degree. One complete rotation is divided into 360 equal parts. Now, each part is 1 degree. Okay, that is what it is written here. If a rotation of initial side to terminal side is 1/360th part of 1 revolution, the angle is said to have measure of 1 degree. Means one complete rotation is divided into 360 equal parts. 360 equal parts. Each part is called 1 degree. Okay, we'll write like this, 1 degree. Okay, representation wise we'll write like this, 1 degree. Okay, one complete rotation is divided into 360 equal parts. Each part is 1 degree. Okay, that is what it is written here. If a rotation from initial side to terminal side is 1/360th part of a revolution, the angle is said to have a measure of 1 degree, written as 1 degree. This is degree symbol. Okay, further 1 degree is divided into 60 minutes. Okay, 1 degree is divided into 60 minutes and 1 minute is divided into 60 seconds. Okay, it is written here 1 degree is equal to 60 minutes. Here mark like 1. Okay, now this is represents minutes. 1 degree is equal to how much? 60 minutes. 1 degree is equal to 60 minutes, and further 1 minute is divided into 60 seconds. 1 minute is divided into 60 seconds. So 1 minute is equal to 60 seconds. Okay, one complete revolution is divided into 360 equal parts. Each part is called 1 degree. Okay, if a rotation from initial side to terminal side is 1/360th part of 1 complete revolution, the angle is said to have a measure of 1 degree, written as 1 degree. Okay, a degree is divided into 60 minutes. Okay, further 1 degree is divided into 60 minutes and a minute is divided into 60 seconds. 1 minute is divided into 60 seconds. Okay, like this. Now here some examples given. This is one complete revolution, 360 degrees angle. Okay, one complete revolution is equal to 360 degrees. Okay, one complete revolution is 360 degrees. Okay, now this is 180 degrees angle. This is 180 degrees angle. Okay, 180 degrees. But this is OA, OB. This is 270 degrees angle. Okay, now one right angle is 90 degrees. Okay, one right angle is 90 degrees. Okay, this is 270 degrees. Okay, now here OA, OB. Now approximate angle we wrote here -30 because this measured in clockwise direction. This is measured in clockwise direction. Okay, these are some examples. Okay, 360 degrees, 180 degrees, 270 degrees. Similarly, you can write 90 degrees. Okay, 45 degrees. Okay, like this, and this is -30 degrees. Approximately we wrote. Okay, -30 degrees because it is calculated in clockwise direction, okay, negative angle, okay. When you measured in clockwise direction, angle is negative angle, okay. The next measurement is radian measure. Radian measure. Suppose this is a circle of radius 1 unit. This is a circle of radius 1 unit, okay. The angle subtended by an arc AB, angle subtended by an arc AB of length 1 unit, okay. This is arc AB, okay, of length 1 unit, okay. Now angle made by the arc at the center, it will be 1 radian. When a circle is a unit circle, okay, then arc of length 1 unit makes an angle of 1 radian at the center. Suppose circle is of radius 2 units, then arc of length 2 units makes an angle of 1 radian at the center, okay. In a circle of radius r, an arc length r will subtend an angle of 1 radian, okay. Observe carefully. Suppose circle is of unit radius, okay, unit circle is unit circle, then arc of length 1 unit makes an angle of 1 radian at the center, okay. Angle subtended at the center by an arc of length 1 unit in a unit circle is said to have a measure of 1 radian. In general, if you generalize, in a circle of radius r, an arc length r will subtend an angle of 1 radian, okay. Suppose a circle is of radius r units, okay, then arc length r units, okay, whichever arc length are having r units, it will subtend an angle of 1 radian at the center, okay. But this is example given. Now this is a circle of 1 unit, okay, radius of 1 unit. Now suppose this arc length is 1, so it will make an angle of 1 radian at the center, okay. Now this is a circle of radius 1 unit, OA is 1 radius, OB is also 1 radius, okay. Now A to B, now this is calculated in clockwise direction of length 1 unit, so AB makes an angle of minus 1 radian at the center, okay. Now this is third case, this is a circle of radius 1 unit, okay, OA is equal to 1 radius and OB is equal to 1 radius. Suppose arc length is 2 units, arc length AB is 2 units, then it makes an angle of 2 radians at the center, okay. If we generalize, in a circle of radius r, an arc of length r will subtend an angle of 1 radian. Means, now example, if you take one more example, suppose a circle of radius 5 units, now any arc of length 5 units makes an angle of 1 radian at the center, okay. Now if you generalize, an arc of length L will subtend an angle whose measure is L by r radian, okay. Now for example, a circle of radius 5 units, then arc length 10, okay. Now arc length 10 will subtend an angle of how many radians? 2 radians, nothing but L by r radians, okay, because L is how much? Length of the arc is 10, radius of the circle is what? 5, okay. 10 by 5 is what? 2 radians, okay. Now that is what it is written. If in a circle of radius r, an arc length L subtends an angle of theta radian at the center, then we have theta is equal to L by r, okay. Theta is equal to L by r, where L is length of the arc, where r is radius of the circle, theta is in radians, okay. Length of the arc is equal to length of the arc is equal to radius into theta, where theta is in radians. Okay, but this is about radian measure. Okay, degree system and radian system. Okay, next relation between degree measure and radian measure. One complete rotation is 360 degrees. Similarly, we know that one complete rotation, okay, now circumference of circle is how much? 2 pi r, okay, where r is radius. So one complete rotation in terms of radians is 2 pi, okay. Since a circle subtend at the center of angle whose radian measure is 2 pi and its degree measure is 360 degrees. Nothing but in terms of degrees, one complete rotation is 360 degrees. In terms of radian, one complete rotation is 2 pi radians. So 2 pi radians is equal to how much? 360 degrees. So pi radians is equal to 180 degrees. Okay, pi radian is equal to 180 degrees. But this is important. Remember this. 2 pi radians is equal to 360 degrees. One complete rotation in terms of degrees is 360 degrees. One complete rotation in terms of radians is 2 pi radians. Okay. So 2 pi radians is equal to 360 degrees. So pi radians is equal to how much? 180 degrees. Now pi by 2 radians is 90 degrees. Okay. 90 degrees is nothing but one right angle. One right angle is pi by 2 radians. Okay. But this above relation enables us to express radian measure in terms of degree measure and degree measure in terms of radian measure. Now we have to be comfortable in both degree measure as well as in radian measure. Okay, we have to be comfortable in terms of both degree measure as well as radian measure. Okay, so what is the relation between degree measure and radian measure? Simply remember this point. 2 pi radian is equal to 360 degrees or pi radians is equal to 180 degrees. Okay, now we know that pi value is approximately 22 by 7 or 3.14, approximately, not exact value. So pi is approximately equal to 22 by 7. So here pi radians is equal to 180 degrees, then 1 radian is equal to how much? 180 by pi. Okay, 180 degrees by pi. Okay, so pi value 22 by 7 if you write, 1 radian is equal to approximately 57 degrees 16 minutes. 1 radian is equal to 57 degrees 16 minutes approximately, because pi value is 22 by 7 approximate value, that is. So 1 radian is equal to, in terms of degrees, is how much? 1 radian is equal to 57 degrees 16 minutes approximately. Okay. Now similarly, now if you want to convert degree measure to radian measure, okay, 180 degrees is equal to how much? Pi radians. So 1 degree is equal to how much? Pi by 180 radian. Okay, 1 degree is equal to pi by 180 radian. Okay, so 1 degree is equal to pi value 22 by 7 if you write, this will be approximately equal to 1 degree is equal to 0.01746 radian approximately. 1 radian is equal to how much more in terms of degrees? 57 degrees 16 minutes. 57 degrees 16 minutes approximately. 1 degree is equal to 0.01746 radian approximately. Okay, radian measure to degree measure to radian measure. Okay, so what is important point here? Pi radian is equal to 180 degrees. So 1 radian is equal to 180 by pi degrees, nothing but approximately 57 degrees 16 minutes. Okay, now pi radian is equal to 180 degrees, so 1 degree is equal to pi by 180 radian. Pi by 180 radian. So pi by 180, this value approximately what will get is 0.01746 radian. Okay, so 1 degree is equal to 0.01746 radian approximately. These are approximate values. But here some commonly used angles given. What we have here, 2 pi radians is equal to 360 degrees. So pi radian is equal to 180 degrees. Okay, so 270 degrees is nothing but 3 pi by 2. Okay, if you multiply 3 by 2 here and here, okay, what will get? 3 by 2 if you multiply here and here, 3 pi by 2 is equal to what will get? 180 into 3 by 2. Okay, so 2 cancel, 90 into 3, 270. So 270 degrees is equal to what? 3 pi by 2. Okay, 180 degrees is equal to pi. Okay, now pi is equal to 180 degrees. Okay, pi radians is equal to 180 degrees. Pi by 2 radians is equal to how much? 90 degrees. Okay, like this. Now pi by 3 radians is equal to how much? 60 degrees. Pi by 4 radians is equal to how much? 45 degrees. Pi by 6 radians is equal to how much? 30 degrees. Okay, these are conversions from degree to radians and radian to degrees. Okay, now 1 radian is equal to how much? 1 radian is equal to 180 by pi degrees, and 1 degree is equal to pi by 180 radian. Okay, here conventional measurements given, conventions given. Okay, now first question, convert 40 degrees 20 minutes into radian measure. 40 degrees 20 minutes into radian measure. Okay, so 40 degrees 20 minutes into radian measure. What we know? We know that 60 minutes makes 1 degree. So 60 minutes is equal to 1 degree, means divided by 3 on both sides. So 20 minutes makes 1 by 3rd part of a degree. Okay, so this is 40 degrees 20 minutes is nothing but 40. 20 minutes is what? 1 by 3 degrees. So if you convert, this one is how much? 41 by 40 into 40, 1 by 3 degree, mixed fraction. So how much it is? 121 by 3 degrees, no? Okay, 121 by 3 degrees. Now if you want to convert in terms of radians, what will write? Pi by 180 into degree value. Okay, pi by 180 into pi by 180 into 121 by 3. Any cancellation? Cancellation not possible, no? So denominator is how much? 540. Numerator is how much? 121 pi radians. So 40 degrees 20 minutes is 121 pi by 540 radians. Okay, what we know? 180 degrees is equal to pi radians. This is a standard thing we have to remember. Okay, 180 degrees is equal to pi radians. Now 40 degrees 20 minutes. Now first of all, minute, second, all these I convert in terms of degrees. So 60 minutes makes 1 degree. So 20 minutes makes 1 by 3rd of a degree. So 40 degrees 20 minutes is nothing but 40 1 by 3 degree, mixed fraction. Okay, I'll write as improper fraction. How much it is? 121 by 3 radian. Okay, now this one if you convert in terms of radian, so what we have to write? Pi by 180 into 121 by 3 radians. Okay, so final answer how much we get? 121 pi upon 540 radian. Okay, next second example, convert 6 radians into degree measure. Radians to degrees, radians to degrees. What we know? Pi radians is equal to 180 degrees. So 1 radian is equal to how much? 1 radian is equal to 180 by pi degrees. 6 radian is equal to 180 by pi into 6 degrees. Okay, so 180 by pi into 6 degrees. Now pi value how much? Approximately 22 by 7. It is in denominator, 7 comes to numerator, 22 in denominator, no? So what will get here? 180 into 6, 1080 into 7 upon 22. If you divide, we'll get it as 343, 7 by 11 degrees. Now 343 degrees and 7 by 11th part of a degree. 7 by 11th part of a degree, but this one will convert in terms of minutes and seconds. Okay, 7 by 11th part of a degree, if you convert in terms of minutes, 1 degree makes 60 minutes. So 7 by 11th part of a degree makes 7 by 11 into 60 minutes. Okay, so this is how much? 420 by 11 minutes. 420 by 11 minutes, what we can write is 38 minutes plus 2 by 11th part of a minute. Now 2 by 11th part of a minute, you convert further in terms of seconds. Okay, now 1 minute is equal to 60 seconds. So 2 by 11 into 60 if you write. Okay, so 120 by 11 approximately 10.9 seconds. So what will get? this 6 radians in terms of degrees is 343 degrees plus 38 minutes plus 10.9 seconds. It is nothing but 343 degrees 38 minutes 11 seconds approximately. Okay. Now here 6 radians we have to convert to degree measure. Pi radians is equal to 180 degrees. So 1 radian is equal to 180 by pi. So 6 radians is equal to 180 by pi into 6 degrees. So 180 into 6 1080. Now pi value 22 by 7 approximately. So it is in denominator, 7 comes numerator and 22 in denominator. Okay. So if you divide, this one will get approximately this value as 343 7 by 11 degree. Nothing but 343 degrees plus 7 by 11th part of degree. Now this fraction part we convert in terms of minute and seconds. 7 by 11th part of a degree, if you convert in terms of minutes, how many minutes it is? 7 by 11 into 60 minutes. So this is nothing but 420 by 11. Okay. So if you convert in terms of minutes and seconds, what will get here? 38 minutes plus 2 by 11th part of a minute. Okay. Now further 2 by 11th part of a minute will convert in terms of second. Okay, 2 by 11th part of a minute is in terms of seconds part we can write 2 by 11 into 60 seconds. So 120 by 11 approximately equal to 10.9 seconds. So what will get final answer? 6 radians approximately equal to 343 degrees 38 minutes 11 seconds. Okay. The next question, example 3. Find the radius of circle in which central angle of 60 intercept an arc of length 37.4 centimeter. Okay. Now here already length of the arc, radius of the circle and theta in terms of radians we have a relation. What it is? Theta is equal to L by R. Okay, theta is equal to L by R, L is equal to R theta. L is equal to R theta, where theta is in terms of radians. Now here theta in terms of degrees given, already we checked, that is 60 degrees is equal to pi by 3 radians. So theta is equal to how much? Pi by 3. Length of the arc, L is equal to how much given? 37.4. Okay, we have a relation, that is L is equal to R theta. L is equal to R theta. So R is equal to L by theta. R is equal to L by theta. So R is equal to L value how much? 37.4. Okay. Into theta is how much? Pi by 3. In denominator pi by 3 means 3 comes numerator, pi in denominator. So 37.4 into 3 by pi. Now pi value is how much? Approximately 22 by 7. So 22 by 7, 7 in denominator comes in numerator, no? Okay, because by 22 by 7, 7 comes to numerator. So 37.4 into 3 into 7 upon 22. Okay, if we simplify, we get answer of 35.7 centimeter. Okay, that is the radius of the circle. Okay, now here we have to find the radius of the circle in which theta is given as, central angle is given as 60 degrees. 60 degrees is nothing but pi by 3 radians. So theta in terms of radians is pi by 3. Arc length L is equal to how much? Arc length L is how much given? 37.4. Okay, length of the arc L is we have, and theta in terms of radians we have. Okay, L is equal to R theta. Using that formula, R is equal to L by theta. We have R is equal to 37.4 by pi by 3. Okay, by pi by 3 we can write as 3 by pi. 3 in numerator, pi in denominator. Okay, further pi value 22 by 7 approximately. So 37.4 into 3 upon 22 by 7. 7 comes to numerator. 37.4 into 3 into 7 upon 22. Okay, approximately this value is equal to how much? 35.7 centimeter. So radius of the circle is 35.7 centimeter. Okay, ma? Up to here we will conclude. We will continue remaining concepts in next session. Thank you.